Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. This time I decided that there's some demo tool stuff that I kind of just want to do. Um, been keeping a backlog of tickets on our demo tool for quite a while. And there's just a few things that I want to go through and fix. I don't know if this will be terribly exciting to people or not, but it's just stuff that I want to do. For example, that when we have file paths in our projects, it should try and resolve the assets relative to the project folder rather than the tool folder. Stuff like that. But at the moment, I just upgraded Rust. So recently I went through and did a bunch of work on the tool just to upgrade everything to later Rust, because for a long time we were on a version of Rust from last October. So about a year old now. And then I upgraded to this. So actually that was a few weeks ago, September 17th. I haven't touched it since then. And then I did a Rust update just now, and it looks like there are some things that were warnings before and are now errors. Particularly null mute here. It's not yet stable as a const function. Of course, I'm on nightly, so I need to just add this to my crates. But this is the kind of reason why we were on such an old version for so long, is that these little things change all the time. And we are using a lot of experimental stuff, so this affects us quite a bit. And that's why I just locked down the version at one point. We just used that for a while. But now I've updated that, and I kind of want to start keeping a little more on top of that, because I think the more fundamental things that were causing issues before, which are mainly due to like allocation, some other things, seem to have stabilized quite a bit more now. So yeah, so I'm going to start actually just by fixing some of these. In this case, I think we just need to add this text to the crate attributes. The crate it's building here is going to be the engine. So it's going to be, oh, that's TinyGL actually. Okay, that's fine though. We can just do that here. So you have feature const function anyway. So should just have to add const pointer null mute. Something like that. That fixes TinyGL, and I expect to maybe have to do this a couple more times. Maybe not though, because that's just setting up some function pointers that will load later. It's the OpenGL extensions. Something you have to deal with. Yes, just to show you. So on the edges of the stickerless cubes, I guess like here the edges are pretty flush, but I guess it could be argued that you could see a little bit past back here. Like there, I think you can kind of see the green a little bit over here. I never really agreed with that rule, to be honest, but I could understand why it was that way. Anyway, it's not anymore, so that's great. Okay, these are the kind of warnings I like. Variable does not need to be mutable. So I'm happy things are moving. There, it built to C++, so yeah, we should be good. I'm going to actually fix these too while I'm at it. I'm just in that kind of maintenance mode on this project. Generally, actually, that's true of my apartment today as well. I did a bunch of cleaning. So yeah, it's fine to let that kind of work pile up a little bit, as long as you know that future you will eventually just feel like fixing it. Yeah, so let's do this. So we'll do git out of another one of these. I mean, if nothing else, this is just what it's like when I sit here and work on the demo tool. Should look at which version I'm on, actually. do also want to address these warnings here too, which should just be in this editor context thing. I don't mind just going through and doing these. I do generally like to keep errors down when at all possible. Then we'll get to the main stuff I wanted to do. I think that's the font I usually use on the stream. Let's just see. Yeah, that is. Can't remember what go to line is in Sublime. Control G, that's the one. Okay, that seems like that would be need immutable context. So, okay. But I guess the binding is fine with that. That's, I don't know, a bit odd to me. But okay. 6-1, 5-6-7, 7-17. By the way, I'm probably one of the only people on the planet who owns at least one Nintendo Switch and did not buy Mario this weekend. And it's totally not that I have anything against Mario. Just didn't feel like playing it. Oh, now it's being helpful in air quotes. I think I can just remove all these. See what happens. Too late, E. Higgs, but thanks. Demotivation is our demo tool. That's what this is. I need to pull up Rocket Editor. And what is demo tool? Let me pull it up. And I can more properly explain. So our demo tool is really kind of in two different parts. We have a sync tracker, which I'll get to what that means in a sec. And then the editor here. Yeah. So, we make demos. Hold on. I did a facelift recently. Did I not merge that? Because that's not what this is showing. Hold on a second. I'm going to merge this really quick. Because the facelift looks cool. I'm actually going to do it this way. Whoops. I don't like to have merge commits in here when we totally don't have to. But yeah, for the demo scene stuff that we do, yeah. No, not git pull rebase master. Nope. Or well, yes. That is what I was going to do. But that's fine. I did it in a weird way and it's fine. Yeah, so okay, lots of questions here. nmake is seems to be Visual Studio, like the weird make thing that Visual Studio uses. To be honest with you, that's all I really know about that. It has its own scripted make thing that isn't make. I haven't really looked much into why those scripts are that way. But the reason we use it is because I actually use QMake for the editor project here, which is sort of the top level thing for the demo tool. And we're not using Cargo alone because there's a C++ layer on top of this, but that pulls in Qt. So by the way, I totally explained a lot of this in a stream I did about the demo tool, but I can explain this a little more briefly here. I don't mind. Yeah, so now this looks a little bit nicer. So yeah, a couple things. This is the editor that we use to make our demos. And it has this graph language in here. The first Ferris makes demos, maybe not the first, like the second or something, goes over demotivation. And then the other ones that go over the specific demos talk about using this. But this is demotivation. This is our tool. And this is basically a representation of the CPU code in the demo, and then the GPU code is done in shaders that are like, I just edit in an external editor. And then the thing on the right here is a sync editor, which is actually separate from demotivation. You'll notice also that engage looks really green right now, and that's because of the thing that I want to fix today. Currently, we don't have per project assets in the tool right now. It's all, the tool just has an assets folder and everything's resolved in there. So I've subsequently, like after finishing this demo, worked on some other stuff, and that had some green post-processing, and that ended up affecting this demo just because things aren't very organized right now. But yeah, so this is demotivation. This is our tool. And yeah, I want to fix stuff in there. So yeah, super high level. In terms of architecture, there's a domain model project, and this contains like a lot of stuff for having a model and the little compiler we use and a bunch of all that stuff. Kind of wraps it up into ultimately this editor context object, which kind of is this big monster object that you could do anything with. And the reason why we do that is because we're going to wrap that in a C API and then consume that from a Qt project, Qt as in Qt, the Nokia thing, or Trolltech, if you guys are a little more historical. And yeah, that pulls in that C API and then adds a bunch of C++ code on top of it, particularly the editor views. So like you saw that grid of ops, there's a bunch of code here to actually interact with that ends up interacting with editor context thing in Rust eventually. So yeah, so that's why we can't just use Cargo, is because we have a couple layers of things going on. And then QMake is the thing on top that kind of ties it all together. QMake, when you run QMake, it generates native build script. In this case, generates an nmake script, and then we run nmake to actually build everything. But nmake, that particular script, actually does use Cargo to build the Rust part. It's here, editor.pro, which is the QMake format. So yeah, so there's some Rust stuff. It'll always go ahead and build this, and it will jump in here. Actually, it looks for this artifact. But it jumps in here and then runs cargo build. And then we link to that. And that's about it. So I don't think it's terribly exciting, these details. But yeah. But I'm going to skim over those and send you to another stream that I did about that. And now I want to work on the thing that I want to work on. Which was that assets thing in particular. Is where I wanted to start. There's a lot of small changes I want to make, like the hold on, just looking through the list here. I'll pull out a few that I can show. Here. So this is actually the one that I want to get to, but I want to do a couple things before this. Basically, our little graph in there, if I can get back to this terminal. When we draw things in this editor, let me see if I can find one. There's going to be some quads here. There's a little operator here. It says quad. Might be hard to read on the stream. In fact, probably is very hard to read. But this editor is more optimized for not using much screen real estate when I'm sitting here making demos. So that's how it's going to be. But yeah, this quad thing, when this is kind of a little programming language, and it kind of goes down and runs all this code, and eventually it draws a quad by calling this quad thing. So there's a bunch of different primitives that it uses. I think this demo only uses quads because it does everything in ray marching. But the idea is that this will draw one quad. And some of these will have like additional expressions so you can parameterize whatever these things are. Just think of them as function calls with some scope. But the quad doesn't have any because it's just going to draw one quad. And one of the things I want to do is use OpenGL instancing and be able to specify, like, I want to draw 1,000 quads, and then that's how we can do a particle system. So that's one of the things that I want to do that I think will be pretty quick. But there's a few cleanup things I want to do before I do that, because in order to test that, I need to actually play with it in the graph and make some stuff. And I have a feeling I'm gonna get pretty distracted when I do that by actually making some effects, which I think will be cool. But that's why I want to do some other things before I get to that, because yeah, otherwise I'm just going to sit and play with that. And that's not something I want to do just yet. Another thing with these ops here is, like, we have different ops for quad and a couple of the other ones, like octahedron, icosahedron, all that stuff. And it's kind of dumb to have that, I think. I'd rather actually have like a primitive operator here and then have a expression where you can select which kind of primitive it is. I think that would make a lot more sense. So that's another thing that I want to do. And then there's this file path thing that I want to do as well. So I think the refactor primitive ops thing is kind of annoying because what I actually want to do is maintain the old projects and bring them up to speed when we make these kind of changes, because that will break the old projects. And I don't just want to do that with versioning. There's some, basically I want to update those by hand, to be honest, just to make sure that we always have those available so we can just like copy and paste stuff out of those projects. And then this one kind of makes sense to do first, because then we can fork out all the different assets for all the different demos and then just make sure everything is up to date with what I had on the branches for the final versions of those. Just in an effort to sort of have those ready on master so I can go ahead and update those when making these other changes. And there's some simpler stuff like refactoring the key map. So like when I want to create these, there's a whole map on my keyboard that just corresponds to different ones. And it uses a lot of the keyboard, which is not too much of an issue because I kind of know where they are and it actually goes pretty quickly. But I do want to refactor the code that actually does that. So that's just some of the kind of cleanup things that sort of accrue in a tool like this that I don't usually clean. I don't usually just do because like they take time away from actually doing demos. But right now is a good time of year to do them actually because it's right after Tursock. Revision is in like 6 months. I don't think I'm going to any other demo parties before that. Might do something for GURP, but we'll see. So like now's a good time in the year to just focus down and work on some of these things. This is not 64K. The tool is actually not that big either. Just I think it's like 30 megs or something, including all the cute stuff. So it's not that bad. But the stuff it produces is for our 64Ks. So this is producing all the data that gets stuffed into the 64Ks, if that makes sense. Metal Void's quick question: how do you generate the sync tracker data for the final project? I can just show you the code actually. So we have all this stuff from Rocket, right? We have all these tracks. And the thing is that Rocket and the tool will communicate with each other. So at any given time, the tool actually has all of the data that the sync tracker also has. And yeah, I'll get to that a bit as well as I explain this. So there's a few different pieces of this. The first thing I do is I do export project from the tool. And this will create a binary blob. So if I just put this on my desktop, I can show you what that looks like. Call it blob. And then I'll pull up a hex editor and just kind of show you what's in there. That went somewhere else. Hold on. Oh, I probably put it in there. I think I know what I did. Oh, it's blob.bin. But I think I also put it in the wrong place. What the hell? Come on, where is it? Okay, ended up as blob. Whatever. But yeah, so I make this blob file. And this has a lot of stuff. So this stuff here gets compiled to a bytecode. And then that's compiled to x86 when we're running in the tool and also in the intro. So the bytecode gets packed, and that's what this first stuff is. Not too much bytecode in this one. After that, we start getting shader code. So there's a bunch of textual data in here. After that, there's going to be a string table with a bunch of uniform names and some other things, which is what all these are. Also various other string names for like the track data and those kind of things. Eventually, we get to some font data. There's also some extra string data in here, which I think I realized recently. I actually want to do an issue for that. Or maybe that's not actually. That might just be the wide character strings that we actually draw. I can't remember. Oh, there's my dishwasher. 1 second. Okay, sorry about that. So anyway, I export that, but I don't usually export it to my desktop here. I export it to a particular folder. Let me show that. Not here. A lot of terminals when I'm working on this stuff. There's a few different moving pieces. So there's a product in here that I call Rivet, and Rivet is the replayer. And it's a Rust project that when you build it, it's an intro. It's a 64K intro. So in here, in the source directory, there is that blob.bin. So I usually export it there. And then, let me show some code there. This in main in particular, there's a lot of stuff for making everything small using no STD. Has some custom linker args for stuff, including linking the Wavesaber stuff, which is C++. Some other things from there, the resources, which includes the icon for the file, the little Logicoma logo. And then what this does, shows a dialog. And if the dialog said run the demo, we're going to run the demo. Sets up some stuff. And here we have a serialized blob, which is that blob from the tool. So we go ahead and deserialize that. Create an asset manager. So it's basically just taking all the binary bits in that and just exporting what it needs. Just pulling all that out and sort of, yeah. And then it actually runs the stuff, creates an audio player. And then while our window's open and we haven't hit escape, we get the current time and we render a frame. Over and over again. So that's what I do. I export it and then I open this project and I build it. And there's a couple other things with that too, like we want to set these pre-render points to sort of warm up the GPU with different shaders throughout the intro. And there's reasons that we have to do that. Basically, when you bind a shader and you bind a bunch of uniforms, depending on like what the GPU wants to do with this stuff, it can usually optimize, especially uniforms. It can bake them into the GPU pipeline in such a way that like it basically runs a little faster, but you end up with this little, usually a couple 100 millisecond glitch the first time that you actually like draw a scene with this particular shader and uniform configuration. And so the whole point behind these pre-render points is that we need to set up a bunch of points across the timeline, basically one for every scene, where it's going to just render a frame with that scene and then throw it away before the demo starts. And that's just going to help it to run smoothly so we don't see these hits when we switch scenes. Stuff like that. But generally the thing is that I export from the tool and then build this project and away we go. In fact, particularly if I go here, I can do cargo run -- release, and that will probably just work. It might not, because I may not have built a couple things. Oh yeah, this null mute thing is also not done. I can just fix that quick. I'll just do it here. Yeah, and then when that runs, we get the demo here. And there is one last step after this, which is that we need to compress it with Crunchy currently, and then away we go. So this is now running. And I think it has the old blob from Engage, so that's what it will run. And there's a couple other things too, like the particular song that it gets built with actually comes from this other project, which we have to build in Visual Studio. So there's some crap there, but it's good enough for what we do. I'm going to commit this, by the way. Of course, that touched the lock file, which is kind of annoying. But not too bad. No, I'm not going to rust a file of it. It makes basically 0 sense to me to do that, to be honest. Like, at this point, especially the synth is already done. And we're not making fundamental enough changes that Rust would be that advantageous to us. Other than being a little bit prettier, which is not enough of a motivation for me to change that to Rust. And the extra build steps aren't that painful either. We're actually going to look into releasing the synth soon. I know I've said that for a long time, but we're actually doing it now. So that's pretty rad. Actually, no, the executable here, once I build this, is not 64K. We need to compress it after that, and that's going to be third-party Crunchy. I think that's, yeah, this is a custom-built Crunchy we have, but it doesn't do much more than just change the watermarks. Because I went in there to try and make it compress a little better, and did it really close to revision, so I didn't have enough time to do it properly and totally failed. So I just changed the watermark stuff while I was in there. That was it. Now I actually have gotten this to compress a little better, but not this version. But yeah, you run that on target release rivet.exe, and we'll output. Actually, I don't remember the command line arguments for this. Release rivet exe. Do that, and then it will build this. And then it's 64K. I think this actually is a little bit over 64K right now. Because after I updated Rust, things got a little bit bigger, and I need to look into that. I think the main thing is the allocator stuff has changed, and that's affected us negatively here by about a couple kilobytes. So not enough to be a huge problem, and I haven't looked into it yet, but yeah. So with the configuration that we built this with in Easter, it was 64K. Now it's a little bit more than that. But then we have the 64K executable. And there it is. So that's sort of the process that we go through to build the actual executable from the tool. But the point is that the tool is what we actually do all the work in. And that's pretty nice. Thanks, man. And some of those things, like I haven't really streamlined the process. Like I could do the crunchy stuff in a build script and all that stuff, but it's like, if you think about how often we actually do that, it's like twice a year that I have to sit there and run those scripts. So just doing it by hand is fine. I'd rather spend my time working on the demos. But yeah. And that export, by the way, the export from here, that does a few things. And that part of that I'm going to touch today, I think, in fixing the stuff I want to fix. It's in, where is it? Okay, I think it's in Opus, one of the sub-projects in here. Export serialization. So we get the compiled program, we get the Rocket client. Yeah, because that's what I was going to answer. I was going to answer, how do we pack in the animation data? That was, so we serialize a compiled program by taking the compiled program and the Rocket client. It's going to go through and pull in the different stuff for like all the includes for all the vertex and fragment shader stuff. Get some big old string chunks from that. Some things about fonts, the text stuff here. I think there's some extra data included with that we don't need right now. Yeah, and then we build this export blob structure here, which includes the sync tracks, where we take the rocket track to sync track. So there's some transformation there, and then a bunch of the other metadata in there. Hey, John Hunter. So yeah, the sync tracks. Rocket track to sync track. So this just goes through all the keys and then translates them. Just pulls the data off and puts them onto something else. Like it's super mechanical, I guess. But then it just, builds them like that. I think you did. You missed my chest and some Rubik's Cubes. And then in the Rivet thing, this has its own code for actually playing those animations. Actually, that ends up being in here, I think. Because we have the export blob here, which has all this stuff in it, including the sync tracks. And I think sync.rs handles actually running these. So for every track, you can get a value. So somewhere in here, we have the static asset manager. No, that doesn't do sync data. Where would the sync data be handled? Is it in render frame? Yeah, here we have the sync tracks. And here we get the value from every track. Sync tracks come from, yeah, deserializing the blob. And every frame we get the value for the current time for every track. Send that into the variables for the grid system. And then when it draws, then it can use the sync stuff. So that's where that data comes from. I mean, it's really the fact that the tool already has the data, and then all we do is just pack it into a different struct and serialize that, and then deserialize it, and then get the stuff. I think it's pretty mechanical. Oh yeah, you can see also there's some debug stuff here when I exported. Particularly that it said like it prepared this font with this big old string which contains a bunch of the letters and stuff. I think this can be deduped as well, but that's fine. Strips a bunch of data, so in this case the font got 84% smaller than it was before. Another font with these letters got 77% smaller. So we do some font stripping as we export. So we put full TTFs in the inter executable, but we go through and clear out a bunch of the sections that would take up space. So that's what's happening here. It's just some debug info for that. Yeah. That's pretty funny. Yeah, I think the reason why this isn't deduped is because this string doesn't get shipped with the executable, so it's fine if there's duplicates. So I think it just concatenates all the strings, and that's fine. And then based on whatever's in this string, we can strip the data differently. Like we can remove all the glyphs we don't use, for example. Hey, Dark Second. So yeah. But I do recall actually finding some stuff about the fonts that didn't need to be packed, and I might as well fix that now actually while I'm in here. I'm fairly certain this export blob had some stuff on it that it didn't need to have. Particularly, it had the text info table. Maybe that was it. I don't remember when or why I found this. I feel like I was streaming when I found it, but maybe I wasn't. I straight up don't remember. We wanted to prepare the fonts. It's this text infos thing, I think. That's somewhat the wrong name. Oh no, compiler text info to blob. Okay, that's actually a good name. Get the fonts. We get the full name for the fonts. We get the value of the text that we're gonna render out. We do UTF-16 because we can. I think we only ever use 8-bit stuff, but this plays nicer with rendering code on Windows. But here, I think I think it was the name string we didn't need here. Oh, you know what? I think this was actually the font name, which it uses. In fact, if we go here, draw text, we'll have the font name and then the particular string it's drawing. So I think that's actually why we need that. So could do an indexed table for that. But I think this is actually okay. Yeah, I'm not going to worry about this now. That looks good enough to me. We're fine there. A lot of those things where it's like, yeah, we could shave off 100 bytes here, but that just does not matter. If this were 4K, that would matter a lot. It's not, and we have bigger fish to fry in 64K. Also, at some point, I think I'm going to start our own sync system to integrate the sync data into this editor, among other things. Been wanting to do that for a long time. I mean, even using Rocket in the first place was more of a temporary solution, which has been a good choice. But yeah. I think I want to fix this asset stuff, but is there anything I may want to do before that? This key map thing is going to be trivial. It's kind of funny because what this is talking about is in the view code for this part of the editor. Collapse some of this stuff. Bunch of smaller projects that build up different pieces of this whole thing. In the op editor, the very top of this is just if this key was pressed, like here, then we create different operators of different types. And this ended up being just this same pattern over and over again because I would just copy and paste as I added new ops and I just never refactored it. So I kind of want to do this. I think I never refactored it because I never ended up with a case where I would actually want to change this logic, which then I would refactor it and then make the change. But since I never ran into that case, I think it was just easier to just copy and paste the whole time. So that's kind of funny. Because this needs to switch event key here. And then, yeah, if it's one of these, it's going to return. Otherwise, it's going to do the other processing. So I think we just do this, though. Put it into a big table. I think because this is cute, I tend to use some of the cute data structures here, either the cute or the C++ ones. Like if I used a cute map here, that wouldn't be too bad. Might as well use the C++ map though, I think. Because I think we can do this. And then just have a big old table here with the key and then the op type. So I think what I'm going to do here it starts with 1. Going to be quite a lot of these. And I kind of have them organized in terms of like categories of operators. So it's kind of, yeah. Yeah, Dark Second, just going through some of the demo tool stuff and just kind of cleaning stuff up. Yeah, so I'm going to comment this one out. Or we'll do this. And then I'm going to go through all these and get them into a form like this. Then we'll do some more formatting on this that we'll kind of be able to clean up all this stuff in one go. We'll get to our initializer at the end there. This will be pretty mechanical. Now the nice thing is this can probably be done with macros. If I wanted to get fancy with the different tasks that I'm doing here. But I think this will be fast enough to just do it by hand. Going kind of slowly here just to make sure I don't accidentally delete some stuff that I didn't want to delete. The other thing I might want to do with this map here is make it static. Because it's not going to ever be modified. But building the map once on key press isn't going to be that bad either. Just knowing how this map isn't terribly large. a lot of entries in this key map, which is actually why I had a ticket on it. Was that I mentioned probably didn't refactor it because we never had a need to, but with refactoring some of the op types, or like I mentioned earlier, I want to refactor like how we represent some things, and that might affect the operator map here. So we're gonna want to clean this up. Really though, I'm just in the mood to clean stuff right now. There's a pretty good reason to do some cleaning. Skay, I can try. But I don't really know how other than to just make more demos. So I might as well give that a shot. The reason I copied this out is because I want to do, we're going to generalize this logic here on this data. So I meant to move this down here. Oh, cool, Dark Second. What's that for? So we're going to do this. We're going to copy all these. We're going to replace these with this. And I think we're going to need commas here. And then we're going to do home, delete all these cases, open those up. Last thing we're going to do is these. I'm going to select the op here just so we can get all of those. This Control D thing. But this is going to be, I think it's like that. Will give us the key value pair sort of initializer that we want. That's pretty cool. And we want this to be a map. It's going to be a map. I don't know if key like that is a type. It might just be an integer. Don't recall. Actually, we should have that up here. It should tell us. Nope, it's Q key event. Q key event has the key, which gives us an int. So that's going to be from int to these op types. And I think those were also ints, but they may not have been. So if I go in here, whoops, it's going to be in this one. Okay, I guess we need to know where they're used. In 32, and that ends up being, I think at this point I abstract that in a couple layers, so I think I have like a project mutator that can create ops, or maybe it's the scene graph mutator. Create op with int op type. So a pretty boring map. Oh, that's cool. Hey, little XMTex. So this conditional stays the same. We don't want control to be pressed. If control's not pressed, we can go through all the key value pairs. I have to look up the code to iterate on a map here because I just don't remember these things. I'm using at least C++11. We should have this range-based 4 thing. Yeah, okay, so this will just give us pairs if we do this. Do an auto ref. I usually like to call this key value pair in key map. And then we're going to do if, I think we had event key. Like this. Then we want to do all this. And then this is going to be kvp.second. Not too shabby. Hey, Wrexham. And then with this, I'm going to close down the editor. And we do nmake again. I got a syntax error, likely because I'm missing a semicolon somewhere. Oh, it's probably just that I didn't include map here. I need C limits for. Oops. Yes, I just need include map. Still didn't like that. Oh, probably this. Don't mind using the namespace there. My LinkedIn, nice. Someone's reading through my my stuff. I haven't read the book in a while. I think there's some outdated stuff in there, but I think the book was really nice. It should have some examples, Jill Hunter. If you just kind of chug through those, that should help. Like they did a dining philosophers thing at one point. Like as far as I remember, reading it in order was really helpful. Yeah, LinkedIn's super annoying. I like going through this demo. Still happy with it. Just cool. Alright, that's actually fine because I just made that there. Yeah, I should actually try some of these before I just commit this. But I expect it'll work just fine. So that's pretty trivial code. And the rest of the stuff works, and I can cause all kinds of havoc here. Look how stable this is, you guys. You can do anything in here. Oh, I love it so much. And then Control Z, undo all that stuff. Oh, I love that. That's how it should be. Super fast, undo, redo everything. John Hunter, I was born in 91, late 91. It is up to date. I haven't turned 26 this year yet. Yeah, it does. It rejits every Control Z. Anytime the model changes, it'll rerun the JIT. It's really fast. Because I mean, it doesn't really do much. Like the compile, so it actually recompiles too. So it takes the graph, recompiles, and then does a JIT on the resulting bytecode, and it's just super fast. Because it's just not doing a lot. Like it never does any I/O. Yeah, I guess I'm a decade older than a lot of people now. How many milliseconds? Honestly, I haven't measured because it's just so fast. Like, I would guess less than 1, to be honest. But I haven't measured. Because it doesn't, like, the JIT is really straightforward. And it's basically just appending to a buffer while maintaining a couple lists for it to fix up after. So just pretty much one-to-one translation into a big buffer that's already allocated. I think I allocate a big 8 meg buffer, and then that just stays, and then I just reuse the buffer. Maybe I reallocate that. Doesn't really matter. Yeah. It only does the it only does the shader recompilation when those assets change. The compile here, I can show you the signature of the function. Because it really, it's not doing too much, I think. It's in this Opus project in the compiler mod. So here's the compile function. You take the position on the grid where you're going to start compilation, and you take the grid itself, which is just a hash map from position to an operator. So it's all pure data. That's a big part of it. And then you get a compiled program, which has all this stuff on it. So it's just got a big old buffer with bytecode in it. It has the names of all the sync tracks. It has metadata for all the render targets. It has keys into a string table. In this case, it even just has actually pairs of strings for the programs, a bunch of stuff for uniforms, a bunch of stuff for the profiler, and then a bunch of stuff for the text it's going to render. So it just gives you all this metadata when it works. Nice, John Hunter. And then it compiles it. So it runs through this stuff. I mean, it's pure data to pure data. Runs real fast. All these passes are really simple. Just visiting some nodes. And then the JIT is also really simple. And then all of these assets that are associated with some of these, like the shaders and the render targets and all of that stuff, those are there's an asset manager that just like looks at the metadata, and if the metadata's changed, it'll recreate the asset or like reload the shader, for example. In fact, it actually doesn't do that on compile. It actually does that on the next frame. Although only one of these is going to happen per frame anyway, but it's going to do that on the next frame when it notices that the metadata has changed. Yeah. So most of the time, it's really only just taking that grid, compiling that into this structure, and then doing the JIT from this bytecode again. And that is in Opus Runtime JIT. This is the JIT itself. So it takes in the opcodes, has this JIT function builder thing, which is in here. So it actually does do a new one. So it does reallocate the memory, and it just reallocates a big old buffer. So 2048 pages of 4K each, which I think ends up being 8 megs or less. I can't remember. I'm bad at math. Let's do this really quick. 4096 by 2048 divided by 1024. Yeah, that's 8 megs. And then it just goes and fills those. Mostly just by pushing stuff onto this vector, with some things with like the loops and stuff that has to do fix-ups with. So yeah, it's really fast. In fact, now I'm kind of curious how long that takes, to be honest. So I know how we can find that out. We can go ahead and in the... where is it? In the editor context. So in our editor domain model, editor context, it's going to be here. Because... I think it's here. Or is it in the model stuff? Model store. So it compiles initially, and then here it needs to recompile. Yeah, because it replaces the model. So that's the other thing too, is that whenever it does any actions, it just creates a new version of the graph. It clones it and then makes the changes, then puts it there. So when it does that, it's going to replace the model and then recompile. Recompile also happens on like open project. I think under redo it's going to happen on any change. So if we're going to measure it, we measure it there. And yeah, not going to worry about the one in the constructor because that's only going to happen on startup with this initial model. We don't care much about that. So yeah, so here we do the compile thing, which calls model compile, which is going to run the compiler that we saw earlier and also do the JIT. So actually it seems like this is the one we want, but we'll do it on the model level anyway, because that's maybe a little easier. And then also it will go and update all the asset tables and the profiler stuff. So I think this is where we want to do this. Yeah, it might be. It might be. I don't think it'll be an issue there, but yeah. Time to bench. So I think I'm just gonna do just some basic time stuff. Where can we get a nice high resolution timer here? We don't want a profile, we want a benchmark. So I think we can use the precise time thing from the time crate. Or is that an STD now? The precise time NS thing is something I've used before. This might give us what we need. Yeah, I think that's enough if we just use that. Bencher? I'm not sure. Bencher. Is that a library? Because it looks like that's in the test stuff. This is fed into functions marked with bench to allow for setup and teardown before running a piece of code repeatedly via call to iter. Because if that's something that we can use outside of the context of a test, that's probably fine. Well, here's a port of the libtest benchmark runner to Rust stable releases. Maybe that's useful enough. Yeah, I mean, if it's just a regular Rust library, then why not? As long as it can actually give us useful stuff here. I don't want to mark this function as bench and test it there because we need a lot of context here. Yeah, sorry, Switch. If you whisper me the link, that'd be helpful. Assuming that's what just happened. Because it looks like it's just going to do... Looks like it sets up an iterator to do a bunch of testing, and that's not really what we want to do here. We just want to measure time that went by while we were in here. I think I'll just go with the precise time NS thing. Which is going to be fine. So I use that in RESTful Boy, and I think it's part of the time. I think we do this in here. Press it's in emulator. Source. Yeah, I'm just going to capture time before we start and then measure the time difference after we finish a single recompile. And then I'll just do the Control-Z thing again. We'll just see sometimes. Just printf those things. System time source uses std time instant here. That even does instant now. That might be okay, actually. Let's just look here. So we should have... Because we have now and we have duration since. In this case, it's actually a lapse that I use here. Which is actually quite okay. I remember the time being quite nice from that, but I don't know if that's going to be the same thing that we want. I think I'm going to pull in the time crate just for this. So we get our precise time NS. That's not going to be too bad. As long as I do this on actually, I'll commit this first. Yeah, thanks for the link. I think I'll just go with precise timeliness in this case. Yeah, so now we can go ahead and do this. It'll be in the domain model project, so this one. Now we'll just go ahead and add time here is something. Just grab whatever the latest is, 0.1.38. Does not really matter too much what we use here. Do extern create time. And then in here, no, here. Something like that. I just didn't like time because we need to use time up here. I'll do it up here. Takes a little while to build because we do release builds on this, and that's for performance. Some of the 3D stuff actually does need it. So this one was quite a long recompile, I think. How many nanoseconds are in a millisecond? Okay, quite a lot actually. Let's go ahead and do this. Where'd it go? It's up here, wasn't it? Yeah, 1E6 should work. Do that. Really? Okay. Oops, we need to rebuild that. According to that, it was about 30 milliseconds. It's not too bad. It's about 1/30th of what I thought it was. It's not too bad. Oh, here we go. So actually, I'm right. Let's do a bunch of these random changes here. No, it's even printing errors. If I just hold undo here. Yeah, that's true, tourist, I think. Yeah, it's going to update all those asset tables. I don't know, because it goes and updates the asset tables. I don't know if it necessarily loads them then. I can't remember what the asset manager does for that. Okay, yeah, so it actually does recreate the stuff here. Render targets at least. I think that's it, actually. I think it just does the render targets. Maybe it rebuilds the text render stuff too. But I think shaders, for example, happen elsewhere. But then it would still make sense if that first one was 27 milliseconds for creating all the render targets. Like if I do this, it also has to recreate them. So you can see that that's a bit slower. But yeah, so we're 1 millisecond, 2 milliseconds, basically at most when it's doing this in practice, which is awesome. The text render, we use it for all the text in the demo. It renders some text to a texture, and then that's what we get in the tool, is we just get the texture that the text was rendered on. So for example, all of this text here, like this conspiracy terminated thing, for example, that's going to be down, I think it's somewhere. I think I have all the text down here. The title texts, don't necessarily remember where this was. But I don't think, so the update's going to be heaviest in the case where it has to do in that first one, because it's going to update all the render targets. And maybe the text stuff. It might recreate the textures at that point. I'm honestly not sure. But in subsequent recompiles, it's only going to update the tables and then like maybe the render targets if I add or remove one. So if that were the case, for example, we should see when I do render target nodes. Those I don't remember where they are. Uniforms, render targets. We may see extra ones there. But I think we have to set some of the parameters here. And these aren't actually getting ran, so maybe these aren't actually hit. So if I do one here, for example, they're getting a bunch of errors and stuff too. Come on, there's the render target. So like these changes might be more expensive. Don't really think so though. But yeah, 1 millisecond for these. That's pretty cool. And about what I expected, because like I said, I've never even noticed it, like in terms of speed hiccups when we're recompiling. So that makes sense. What was I about to check though? I was going to check something. Oh yeah, where this text was. Let me just expand this out. So I just don't remember where I put that on here. This is the whole demo, so they're going to be somewhere. Just don't know where. Oh, they're all up here. Resizing the window also recreates those, so it's sluggish there. But yeah, so like this text conspiracy is a rad group, guys. Then we can change that, and then it'll recreate those textures. And so there, I guess the update is updating the text stuff there, because then you can see this 3-4 milliseconds. So it's probably also updating those textures whenever we do that. Now you can see the flickering doesn't actually align with the characters, because that was some hard-coded constant I put in the shader. But yeah, I mean, practically speaking, this is fast as shit. So we do not notice these recompiles. So I'm actually really happy to see this. But yeah. I'm gonna get rid of that. I can even double check that, like, so we can see here that it's updating the render targets, and there it's going to create new render targets if they've changed. And then in the case of the text render, it's going to update that. I think that struct is even in here. The cool thing about this too, though, is that the code is not terribly complicated. Where's this coming from? It might be in expunge. Expunge renderer. It's probably in here. No, it doesn't update. It's going to be separate. It's going to be somewhere in here. Expected it was in here. Okay, it is here. Yeah, so update here. And yeah, it does re-render the fonts. So that makes sense. So some of the compiles where it has to actually update assets, which arguably could be a different part of the thing than compiling, but it just kind of makes sense to do it there. I mean, I guess what that shows, though, is that the actual compile, which is where it does the JIT and everything, is also separate from updating the asset maps. So if we just measured this, that would be the compile and the JIT, and that would definitely be less than a millisecond, or around a millisecond like we saw. And then updating the assets is also pretty fast. So I think that's pretty cool that it's that fast to do the JIT again. Because I mean that's been what's kind of the fun thing about this too. It's just that never gets in our way. Plus it's cool. It's cool to have a JIT in your demo tool. It's the only reason we have one, to be honest. It's fun to make. But yeah, closed one ticket today. Yay. Man, I felt pretty good about this JIT before, and now I feel real good about it. I think this is the one I still want to do next. I don't know if I want to do that now, though. Just looking at the time already. This is going to be mostly moving files around and fixing up all these projects. It's going to be where most of that time goes. Making sure we have the right versions of the assets this will use. So yeah, I don't think I'm going to do that now. In fact, I think I'm going to go, because it's 9:30 already. I'm going to do that. I'll probably work more on this week. Maybe next week will be more of the same, or maybe next week I'll be playing with effects. Who knows? But yeah, I think I'm going to head out. Thanks, guys, for hanging out. This is pretty fun. And I'll see you on Thursday.